Good morning, friends. This is Desigan, Assistant Professor, Department of Mechanical Engineering, King's College of Engineering, Panalkulam. So, in the paper ME 8691, Computer Aided Design and Manufacturing, in Unit 2 of Geometric Modeling, the topic today we are going to discuss is about constructional solid geometry. So, in this syllabus, the last keyword given in the syllabus is CSG, that is constructional solid geometry. So this is nothing but how the constructional surface are feed up into the computer aided design and manufacturing. Nothing manufacturing in CAD software. How the models are to be implemented or to be interpreted in CAD. So CSG, constructional features are as follows. First one is quadratic surfaces, and second one is ray intersection with quadratics. The quadratic surface is there, it is bisected into two, that is second one. Third one, set operations, that is mean union or intersection or equal to or not NAND. Likewise we have the set operation and the ray classification. These are all the things we are going to see in CSG in the upcoming slides. Consider a sphere. Consider a sphere is having three-dimensional sphere, not a two-dimensional object. A three-dimensional sphere. It is having the specific equation of x square plus y square plus z square is equal to 1 or less than 1. It cannot exceed 1. That is the thing they are going to convey. Next one, the cylinder is x square plus y square is less than or equal to 1. These are all, we call it as a general quadratic surfaces. So quadratic surfaces is having 4 cross 4 matrix. Suppose the x, y, z, a, b, c, d, e, f, g, h, somewhat. Just it is given. We have the 4 cross 4 matrix, and P transpose can be used for the effective boundary condition. Any quadratic surfaces is going to analyze as a constructional geometry means first we have to go for the highest power of the coordinate. When a coordinate is there, we have to go for the highest power. Based on the highest power, the equation can be derived. Suppose the highest power in the geometrical quadrature is square, means 2. 2 means we have to go for the equation as ax square plus ay square plus hz square plus 2bxy plus 2cxz plus 2fyz plus 2dx plus 2gy plus 2fz plus j. And j is a trigonometric function. Remaining in the equations are termed as a quadratic function. Total equation we have to make it up with 0. Next one, some special cases. If a sphere is there, cylinder is there, some circle, two-dimensional object like circle is there, and quadrilateral is there. Other than that, some special function we have to go for specific equation. For a plane surface like a circle is there, we have to go for first one, ax plus by. This is the normal polynomial equation. Ax plus by plus cz minus d is equal to 0. In this, all the dimensions from the center is equal because the radius of the circle is equal from anywhere of the end point. So we call all the dimension like a is equal to c, that is equal to b, that is equal to h, that is equal to f, all are equal to 0. 0 means a constant. We have to put value 1, 2, something like that. So next one, the 2D is equal to capital A. Capital A means the diameter. So 2 into small d, we call it as capital D, maybe capital A, somewhat like that. We have differentiate. The minus d is the function that is termed as a Cartesian coordinate, and the minus d and minus r square, and in cylinder we call it as, directly we put it as minus 1. These are all the Cartesian equation. That means there is a two dimensions are available, radial and Cartesian. In Cartesian, when we take in from the radial equation, we call it as a Cartesian as a negative part. When we take Cartesian equation, we take radial is a negative part, but more or less the radial equation are available more, so that we put negative for the Cartesian equation. Next, the cone and parabola, ellipse, hyperbola, interceptors are all having the same idiotic function, except paraboloid we have a negative coordinate, so we put negative. So in this properties of quadratic equation, we go for a M transformation matrix, that is transpose of the minimum periodic function. Next one is very important in terms of constructional solid modeling. In this construction solid modeling, the ray intersection is unified representation for a ray algorithm. Ray intersection is the unified model for the ray algorithm. In this ray algorithm, we have to go for an equation P T, that is equal to P plus TV, that is less than or equal to 0. The same equation we followed in the quadratic, but in terms of complex numbers, or in terms of negative numbers, or the equal value of a tangent, we go for a ray intersection. Next one is set operation. Already we know that set A intersection B, A union B, and A transpose are some of the set operation available. We are studied in a lower classes in mathematics. Likewise, the set operation is also performed in this constructional solid modeling geometry. So in regularization operation, the closure, the inverted U is called union, and normal U is called union, the inverted U is called intersection. For example, this is the simple example that is given in this. In this set, A is opened. In right side, first see the right side diagram. In the first diagram, the A is open and it is having some subnormal extension. Second diagram, the B is closed and it is having some subnormal extension. Then the C is there and all the dimension are set free, so it can be easily identified. And the fourth one, all the sides are closed and there is no subnormal extension. These are all the simple example how the inputs are available in this constructional solid geometry. In this constructional geometry, we have a set which is closed with interior and regularization as mentioned above. So the CSG operation, how the constructional solid geometry operation is held in difference with regular operation, that is A union B intersection C minus D, that is expressed in binomial tree. This is the simple expression of binomial tree. The equation is given in above. A union B, that means when the union is there, the symbol is available between these two functions. The A is again available with the same thing along with the C, but the symbol is changed as intersection. And from the all these thing we have to minus, and the minus is put there. From the above equation, it is explained very clearly. So the CSG data structure tree is how we tell it is uplift tree. Likewise, they tell Op means operation, and tree means the available base structure, and the leaf means the program we are going with the operator. In this intersection ray, the solid modeling technique can be used to proliferate the intersection tray along with the parametric value of T0 to Tn, T0, T1, T2, T3, whatever it may be, the parametric values can be used for this intersecting ray. We have to combine this function. L is called left ray and R is called right ray. L union R is the completion of these three functions. L intersection R is completion of these two functions irrelevant with the L and R. L minus R means totally the L is there and the length of R is minus, all is subtracted, and we get this simple equation. So with the help of this solid modeling technique or constructional solid geometry, we provide simple methodology for the set operation of the solid to provide elegant operation, and especially with the simple classic shapes. And other type of representation, it do not require the quadratics, and it can work with the help of the solid representation modeling. These are all the some basic things about the constructional solid geometry in unit 2 of computer aided design and manufacturing. Remaining we will see in the upcoming video. Thank you.